over the world, the reduction of water loss and waste is a key issue in water distribution systems, especially because of the increasing demand for fresh water from the population. On the other hand, the increasing costs of the water and the energy required to provide it to the aqueducts. This becomes more important in regions characterized by water scarcity or even drought. Water loss is defined as the difference between water pumped into the aqueduct system and billed water. Water loss occurs in every water distribution system during its overall operational lifetime. That's normal indeed, but the percentage must not be excessive. Geographic information systems, GIS, monitoring and databases are particularly helpful in reducing water losses. The basis of the activities is monitoring of flow and pressure in water supply networks and active leakage control. Network zoning with simultaneous observation of minimum nighttime flows allows for preliminary location of the failure. Equipping companies with special leakage detection devices such as geophones, statophones or correlators enables quick detection of leakages. The next step is to replace water meters with more and more accurate ones and to implement radio reading of water meters. All water companies perform systematic replacement of old steel and cast iron pipes, which cause a large number of leakages that are often difficult to identify, thus leading to water losses. But this often requires a lot of time and a lot of money. So, dividing the distribution network into sections or districts is a more immediate and cheap intervention. In fact, pressure management is considered the single most beneficial, important and cost-effective leakage management activity. The higher the pressure in the distribution network is, the more water is lost through bursts and leakages in the network. Furthermore, most pipe bursts occur due to ongoing pressure fluctuations, forcing the pipes to continuously expand and contract, resulting in stress fractures. Water theft, illegal connections, and unauthorized use is a huge problem in many parts of the world. Dividing the supply network into sections, DMAs, is an efficient way to get an overview of illegal consumption and where it takes place. Also, there are practical ways to secure easy targets, such as hydrants. Yes, wasting water is actually bad for the environment. There are anthropocentric, biocentric, and ecocentric reasons why wasting water is bad. Anthropocentrically, fresh water is a vital resource for the survival of our population. Biocentrically, other species rely on fresh water besides humans as a vital component to their survival. Overuse of fresh water in household settings means there is less fresh water for agricultural use or vice versa. But many livestock species rely on fresh water. Also, as we divert more fresh water from aquatic environments to supplement agriculturally, many plant and animal species are threatened or can become endangered. Ecocentrically, wasting water while our demand for water increases as population and standards of living increase globally means that we need to supplement for this lack of fresh water by pulling it out of aquifers or groundwater supplies in which the regeneration rate is lower than the extraction rate. This unsustainable practice decreases long-term water security and availability. By far, the most relevant amount in water waste reduction is related to agriculture irrigation and industrial processes, both in terms of planning new uses and in terms of optimization and revamping of existing uses. There is also a number of simple measures to reduce freshwater waste in residential areas. There are different quite simple good habits that must be adopted by everybody. Avoiding toilet leaking and faucet dripping, not leaving water on when brushing one's teeth, avoiding over-irrigation in the urban gardens. It is also important the rainwater harvesting and the reuse of grey waters for non-potable purposes, as well as the large-scale adoption of high-efficiency toilets, which require less water per flush. Moreover, faucet aerators are very inexpensive and easy to install as low-flow shower heads. The high-efficiency washing machines are also another very important technological innovation, allowing a reduction in freshwater demand. Water loss and water waste are a critical issue in many parts of the world and not only in developing countries. To overcome the challenges, we need to increase awareness of the many already known and well-proven techniques for efficient water management. Knowledge sharing is the key to ensure that the water sector is ready to meet the needs of tomorrow. This concerns technical solution insights as well as a holistic view on the complete journey of water throughout society, from ground to tap and safely back into nature.